ERDC, the Engineer Research and Development Center, are the Army Corps of Engineers Research and Development Laboratories. And just like the rest of the Corps of Engineers, we work for the Army, the Department of Defense, federal agencies, and really organizations around the world to solve some of the world's toughest challenges. This country needs us. It needs places like ERDC to solve these huge challenges that it's facing today with the climate, with the infrastructure, with the people that want to do us harm, with our environment, with all these big issues that this country is facing. It needs places like this one. So ERDC is made up of 7 laboratories, but dozens of collaborations, maybe thousands of them. We have our laboratories to keep our technical expertise up in certain areas, but the biggest issues are all cross-laboratory, cross-disciplinary, multidisciplinary type issues.
We seamlessly work across our laboratories, and we seek to work together because we recognize that we cannot solve tough challenges alone. The credibility that our people have is invaluable because when they speak, people listen, and so we're able to help our customers get over some hurdles. We are intensely passionate about how can we serve them better, and bringing the best science, engineering, and technologies to the table for them to be aware of, constantly seeking new knowledge so that we're on the cutting edge and providing what they need is where we get our energy.
When you say you're world class, you have to be willing to work with the world. And that's exactly what we do. We work with the best in Germany. We work with the best in Switzerland, England, Japan, Canada, Australia, Italy. I mean, these are world-class engineers and scientists that they're dealing with some of these same issues that we're dealing with. They understand and respect us. They wouldn't be working with us, frankly, if they didn't. But we respect them as well. And we're more powerful when we work together internally and when we work with our partners, industry, academia, and our sister laboratories. These challenges are even bigger than ERDC.
I think what I would want a customer to know is we do what it takes, whatever it takes to solve their problem. And we care about our customers. We are intensely passionate about how can we serve them better. That's what matters to us.
So world-class facilities, world-class people, world-class mission, it's a hard combination to beat. The power is the people and the willingness to work together to solve these common problems that we're facing as a world today. We can think out of the box on any kind of a problem you have and apply it to any challenge we face in our mission areas. So when you have an anthropologist working with a geospatial engineer, working with a computer scientist to come up with a predictive tool for Afghanistan, that's a very, very powerful combination. Who thinks of things like that? We do, and we bring that to the game every time.
Our country is facing a bit of a dilemma with its aging infrastructure. Everybody knows that the infrastructure has gotten a bit older than it should be, but we can't manifest all of the money and the manpower that we need to repair everything to what it should be repaired to.
Corrosion is costing the Department of Defense $20 billion with a B per year. That's the cost, and that is a big cost.
There's a lot of science that goes into keeping the environmental conditions off the surfaces of our infrastructure. Because it's when the moisture or the salt or the UV start hitting the materials that create our infrastructure that cause it to start eventually breaking down. Our locks and dams are part of USACE infrastructure, and these are largely made of steel structures that some are in mild conditions, but some are in very harsh conditions. And without the coatings on them, the maintenance on them would be at a rate of at least yearly. And when we start shutting down our locks and dams to do maintenance, we're shutting down a global system economy. And most people don't realize that you can shut a dam down, but you're stopping the shipment of important goods from one side of the country to another. And so being able to put on a coating and help protect that structure 40, 50, 60 years from maintenance keeps that cost down and makes sure that our economy is flowing.
If we can do a dent of like 3 billion per year, inventing like new coats, different ways, different material, different setups that can avoid the rapid deterioration or prolong the age of the assets and the infrastructure that we have, we did take a bite out of that problem.
When I came to the ERDC, I began looking at different ways to assess infrastructure. The low modes of bridges, which is the way that they flex, happens to be in the infrasound passband. A really big bridge bends in really big ways and creates low frequencies. So I looked at the possibility of using these structural acoustical emanations as fingerprints for those structures to determine how good they're feeling. And if you can do this from non-line of sight, tens to 20s of kilometers away, you can monitor wide areas with a very small manpower footprint with very affordable equipment.
An example of work that we've done in the past is like the reinforcing of the Pentagon. So before 9/11 actually occurred, the Corps of Engineers here at ERDC was helping with the redesigning of how we reinforce the infrastructure itself, everything from the windows to the walls to the supporting structure within inside the Pentagon. And by happenstance, the area that had just been refurbished in the Pentagon was the area that was hit by the plane on 9/11. So numerous lives were saved because of that sort of facilitation of re-enhancing or enhancing the Pentagon facilities.
Our simulators are used for channel design. It allows us to move things around really quickly and test a lot of different scenarios and see what's feasible. Whether you make a modification to deepen, to widen, to increase the dimensions of a turning basin, engineering regulations says you must simulate those changes. We can test so many different scenarios. We don't destroy any property, we don't break anything, we don't hurt anybody. And by doing that, we reduce the risk of us doing those very things in the real world. We reduce the risk of running a ship into the Riverwalk in New Orleans or spilling oil in Prince William Sound. And that's how we make this a safer place for everybody.
Well, we are in Hangar 2. This is one of our accelerated pavement testing facilities here at ERDC. And the piece of equipment that's behind me is our heavy vehicle simulator. And what's special about this facility and this equipment is that it allows us to put 20+ years of traffic, whether it be aircraft, vehicle, rail traffic, on a test section within a few weeks. We develop materials, tools, techniques that can be implemented in the civilian sector. Some of the materials that we've identified to repair airfields can also be used for dams. It could be used for roads. It could be used for civilian airports and airfields.
The Engineer Research and Development Center is developing many materials for the rehabilitation and repair of infrastructure, making it easier, quicker, and cheaper to provide improvements to our nation's infrastructure.
We solve impossible problems, and we let our researchers really explore their imagination to find out how they fit together and how we answer the Army's needs now and tomorrow.
In the battle space, everything starts with a map. It gives you common situational understanding of where you are, where the enemy is, what you have to do. It talks about operations, logistics, intelligence. We put that capability together. So now what used to take years to develop a plan for a theater now can take hours or days or weeks. And even better than that, now that you have a plan, it can adapt as the environment and as events adapt.
One of the foundations of the ERDC is that we're part of the Corps of Engineers, and they have been historically the Army's mapping and geospatial science experts. And with that history, we carry a legacy of topography and just geospatial analysis for years that has made us an expert in this field.
They often say that a picture is worth 1,000 words, and I like to say that a map is worth 1,000 pictures. There's so much information that you can convey within a map and be able to explain it in an easy and understandable way.
In the case of being in theater, an area can change vastly in just a number of days. It can change from when you went and drove a route yesterday to today. What we really focus on is how do you first get the highest resolution, highest accuracy, highest quality.
The ERDC, especially our group, is looking to ramp up the timeline from when soldiers get those maps. The maps that they have in theater might be a year, 2 years, even some 5 years old in some cases. Well, if you can deliver these map data on the fly, then they will have a common map background to work from in a matter of minutes or hours.
The bigger picture of why we are using these highly capable sensors and this very new and upcoming technology is that we live in a world that's changing. And all of that ties back to being able to have the most up-to-date information.
So we are developing a tool called Plans. It is an online tool for military planners to quickly determine the throughput of logistical supplies from point A to point B. Plans is very easy to use. You simply put in where you want to start and where you want to end, and behind the scenes it's automatically pulling all this data for you. And it's running all these complex models behind the scenes. We can do this within minutes versus now it usually takes about a month to do these plans.
One of the technologies that I've been fortunate enough to work on is a dismounted routing software. And by dismounted, I mean on foot. So when we think of routing, you might think of Google getting you from A to B. And that's what we were trying to do for the soldiers on foot. But the idea was to incorporate the extensive heavy loads that they're carrying on their back, the slope of the earth, the speed at which they're moving, to try to pull all that together and make their decisions about how to go from point A to B on foot a little bit better. One of the other concepts that we pull in is a basic geospatial analysis called line of sight, and that's trying to figure out where somebody can see in a particular area or where somebody cannot see. If we know a pilot went down an area, how far can he maneuver in a particular area in a given amount of time? So can we place a cache and placement site or supplies for him to get to based on the distance we know he can travel based on the surface of the earth and the kind of gear he's got on him.
We're working on an augmented reality project where we're trying to fuse in geospatial technologies with augmented reality. For instance, if they're in the back of an armored personnel carrier.
We are all patriots. We love our nation and we want to protect people and our soldiers. And even domestic terrorists. We have a lot of ERDC people involved in protecting us against domestic terrorism. So there's this heartfelt that we all have, that we work and work and work to solve these problems because we believe in it.
Logistics, operations, fires, intelligence, all on one map at the same time. It's never been done before. We put that capability together. So now what used to take years to develop a plan for a theater now can take hours or days or weeks. And even better than that, now that you have a plan, it can adapt as the environment and as events adapt. And so map-based mission planning technologies is a game changer for the future. We're building that not only for the warfighter, but we're envisioning ways that it can be used beyond the warfighter in the future. ERDC supports disaster relief in a lot of ways. So the Corps of Engineers actually supports FEMA in its mission to responding to disasters. And what the ERDC can do, we can do modeling and simulation so we can predict what the inundation levels or the water levels will be after a flood or a surge. We can come up with temporary bridging strategies to cross rivers and streams as the real bridges get washed away. We come up with reach-back capabilities so the people in the field who desperately need solutions can call right back into us and come up with solutions that they're facing every day. So we support disaster response in all kinds of ways through the Corps of Engineers and others in providing that kind of relief.
If there is a natural disaster and something that the military needs to respond to, we have capability within ERDC to estimate what those impacts are, but also estimate the timing and the scale and the response that's required. So the ERDC has capability for assessing food, water, energy under changing environmental conditions. We do vulnerability assessments.
On a river flood situation, you might have areas where you have high water, you may have inundation. You want to look at how that overlays with your population centers, your critical infrastructure. Total Watershed Decision Support is an integrated system of models starting from the upper watershed, so you have the precipitation, rainfall, snowfall, stream flow network that comes through, flows over land into rivers, and then down to the coast where you have waves and storm surge, tides. And then through the modeling, we would come up with almost a stoplight system. Green, things are good, red, things are bad. So they could look at how these different parameters overlay each other to tell where they might have problems coming up.
With 3D printing, what it allows us to do is rather than do the traditional concrete formwork that you see in most construction, is we have a system where just like your little 3D printer that you see on TV, but now it's scaled up, and we're able to print that structure one small layer at a time. Well, the benefits of 3D printing is, one, we believe we'll be able to use locally sourced materials, so we don't have to ship them in from the United States or other areas of the world. So 3D printing also reduces the amount of labor required to put up a structure, because in those environments, especially in a disaster relief scenario, there's no local labor available. Everyone is just trying to recover. The fewer labor resources you have to engage, the quicker you can get critical infrastructure in place.
With building supplies in particular, they're pretty bulky and represent a significant logistics burden. You would take waste products in an area like brush or maybe even shipping pallets that were used to deliver other products, grind those up using something similar to a wood chipper, and then coat that material with microbes that then can be used to grow in a micellular structure that has properties very similar to foam board insulation.
So I'm standing here in front of the improved ribbon bridge, which is a portable bridge the Army has in its inventory. Now this bay can fold up into small pieces. It can be transported by truck or helicopter and assembled in a river to cross rivers of any width. And what we're doing at ERDC is trying to do testing to take it to the next level. We're conducting hydraulic and structural modeling to see what the limits of the bridge are and just how fast of a flow and how heavy a weight this bridge really can support safely.
Natural disasters affect water treatment plants. They make it very difficult to provide the local citizenship with clean water. This is called the Decontamination Effluent Treatment System. It can treat virtually anything, including bleach, including soaps that are in the water. It's a very robust system. It's what we call an agnostic system. This can treat anything, any kind of water. It doesn't care what chemical it is, it can treat it.
Another piece of technology we have is called the hybrid power trailer. Think of it as a Prius for operating in remote environments. The generator only runs at top efficiency to charge the batteries, and when the batteries are charged, that supplies the power to the actual facility. This particular system will reduce your fuel demand over a standard generator by 80%. Instead of your fuel supply lasting for 2 days, it would now last for 10 days.
What the ERDC does is to provide assistance in things like water and bridging and communications, critical things that you need immediately following disaster and then as we respond to that disaster.
We are looking into the future installation. We are trying to conceptualize, design, build an installation that would be safe, environmentally compliant, energy efficient, well located and suited for the surrounding community and environment, and more important than anything else, less expensive to operate and run.
The Army identifies training as an enduring requirement regardless of where the technology goes. Despite all the advances that we've made in virtual and gaming technologies for training, live training will always be a key component that brings it all together. So from that perspective, these training lands are important to us now, they'll be important to us in the near future, and they'll be important for us longer than that.
There's an ammunition depot in Alabama. The Army's been there for many decades, and there's a contaminant in the groundwater. There's a species of fish that lives in an impounded area, and it only lives there. It doesn't live anywhere else in the country, and it's being exposed to TCE coming out of the groundwater. We got involved on behalf of the Army to say, not only is the level they're being exposed to okay, they can actually be tolerant of a much higher level. So that's an example of kind of a site-specific case where we can provide data for not only the Army, but also the regulatory community in ensuring that installations stay open and that training continues.
Our bases are no longer out in the middle of nowhere. When many of them were first established, there was nothing around them for miles and miles, and now we have urbanization around the fence line of every single Army base that we have in the US. And so we have to learn to work together with them and integrate into that urban landscape. Neighbors don't appreciate loud noises in the middle of the night or smoke or dust encompassing their backyard on a beautiful Saturday afternoon. So ERDC has a whole noise team or acoustical engineers that help solve these problems. They have monitors that they can install to understand what noise is generated and under what weather conditions. So if it's cloudy, that can certainly hold in the noise or the dust or the smoke, and wind patterns can blow it where you want it to go or where you don't want it to go. The real challenge boils down to being able to integrate into these neighboring communities in the surrounding area, that you're able to have a positive impact environmentally, socially, and financially.
One of the concepts for future operations is forward deployed environments. These types of technologies are very important in protecting those, what we call projection nodes, and that's how the military, both the Army, Air Force, Marine Corps, and Navy, would move into an environment. The military doesn't always have the engineering expertise that they need downrange. They can't calculate dynamic effects of structures, so we do all that here at the research lab. We understand the weapons effects on these structures, we engineer all of that into the structure, and then we deliver kitted components so that all they have to do is assemble them in their austere environments.
The research that we do here is basically to support the warfighter in the nation against terrorist threat activities, whether it be government buildings here in the U.S. or Army facilities nationwide or overseas. Our customers will give us a specific threat level, and we will dial that into our blast load simulator that's housed underground, and then we will subject our different materials, like for instance the one behind me, which is a reinforced concrete panel, that we're seeing what the response is to that particular air blast pressure and impulse combination. We have the ability to test and evaluate those things here, much more efficient, economical fashion than if you were at a high explosive test site.
Our shake table is for vibration testing, and it was originally built for shock testing. Our table is capable of very high forces and high frequency. This provides the ability to test very massive equipment specimens. So we've tested, for example, generators that are 3 megawatt generators with fuel tanks weighing about 150,000 pounds altogether. So our lab is uniquely able to test heavy equipment like that. So we're the only table in the country that can test something weighing more than 30,000 pounds.
The reason why we do these on supercomputers and not like your laptop is that we have really large problems to solve, and sometimes we have simple problems we have to solve very, very fast. And so we can run these simulations on supercomputers millions and millions and millions of times. Things that would take millions of years for a laptop to solve. The advantages of being able to run simulations like we do on these supercomputers is that we can run hundreds and thousands of these simulations over and over again with different environments, different conditions to see the effectiveness of the work. It's sort of like similar to that Tom Cruise movie where he dies, shows up again, fights aliens, he gets killed, dies again. And, we can do that millions of times when soldiers don't have to die. We can do this all in simulation and provide really good answers from the Department of Defense.
The Army Corps of Engineers has had the mission for building military installations since World War II. And so the ERDC has been helping think about installations and how they support the soldiers in their training and readiness mission. But we also have to do that with the environment. How do we make them more energy efficient? How do we support new technology? How do we make them cyber secure? How do we help them do the kind of training they have to do to prepare for the missions that they're going to be facing in the future? That's what we're doing. One of ERDC's strengths is really understanding the environment and its effects on who we are and what we do. We actually are the world's experts in how things operate in the Arctic in very cold regions. We have a permafrost tunnel, so we understand how permafrost affects our ability to build and operate in Alaska and other areas where permafrost is. So if you understand how the extreme weather events and extreme environments around the world impact you, you need to work with the Arctic.
At ERDC, up near Fairbanks, Alaska, we have a permafrost tunnel. And as you walk through it, it's almost like you're walking in time. For the first time, we captured ancient biodiversity in there, and we're looking at how those changed over history. And the reason that it's important is because we're in a time of change. So extreme environments are new to us, but they're not new to our history. So we can relate and forecast what the ecosystems might turn into based on looking at the genetic material stored, frozen in the permafrost.
So as conditions change in the Arctic, a lot of our modeling assumptions that have gone into predictive models in the past are no longer as valid as they were before.
Our model is not only predicting that a crack is going to form here, but there's a 50% chance or 75% chance that the crack is going to form within this area or in this direction.
One, allows us to plan appropriate routes for these particular platforms, and two, also allows us to design perhaps new platforms that can operate in these conditions. As there's more and more commercial activity in the Arctic, we need to have an engineering tool to be able to build structures and ships that are resilient to those forces.
In the high Arctic, we're focused on oil remediation because decades ago, essentially, there was military activity and oil contamination. And so traditional remediation technologies, physical and chemical, have failed because it's so cold up there. Oil is not just one thing. It's actually a mixture of a whole bunch of different molecules, some really easy to break down and some really difficult. So microbes have the genetic capability to break that down so that it's no longer harmful to humans and wildlife in the area. And microbes are really special because they have a versatile appetite and they can break down these complex compounds. Imagine using plants and microbes to break down oil. That's what we're doing here.
The research that I do in ice engineering is very different than what's traditionally been done in the field of ice engineering. And I, as a materials scientist, look at ice as just another material. And what can I do to manipulate its properties, to possibly make it resistant to melting or to make it stronger? Everyone knows the story about igloos, right? So igloos are the ice structure that's persisted in the Arctic environments for a long time. But can we really take that and optimize ice so it's a high performance material and build things that are a little bit more sophisticated than igloos?
In 2016, we actually completed the construction of the first deep snow runway named Phoenix. This runway is constructed for wheeled aircraft, and it sits upon 70 feet of snow, which then sits upon 100 feet of ice, which is on top of the ocean. Very first time coming in during a test flight on that aircraft. I was nervous and excited at the same time for doing something that was the first in the world. As soon as that aircraft started to come in and it landed, the happiness that rolled over everybody on board, the cheering that took place from the pilots all the way down to the airmen in the back. We never know what kind of environment we're going to be getting into in the future. And being able to build a runway to bring in people, personnel, and logistical needs to anywhere in the world, ERDC did that. ERDC's doing that now.
The ERDC has a lot of expertise and understand the environmental effects on things that we do in warfighting and in civil works, particularly extreme and harsh environments. How the permafrost affects our ability to operate in Alaska, how it affects structures and that sort of thing. So if you want to understand how to operate in an extreme environment, whether it's a desert or whether it's the Arctic, come to ERDC.